Hello. So I wanted to make a supplemental video to go along with lecture this week. If you look at the end of the notes, there are a few sets of examples on nomenclature to wrap up our nomenclature that we would go over after class time if we needed some extra time. So we're going to use that time today to go over a few additional problems at the end of the notes. This slide and the next two slides I will also review in class on Friday again. So I just wanted to kind of wrap up in this video the nomenclature for organic alcohols so that when those examples pop up in the last few examples, we'll be on the same page as each other. So we'll see this slide and the next couple of slides again on Friday. But the idea of an alcohol would be if we take something like methane, replace a hydrogen with a hydroxyl group, which is this OH group, that we would call that compound that results something like methanol. If you replace a hydrogen on ethane with the OH group, we call that ethanol. If you do this on a propane ring, we call this propanol. And you do see this like little number out in front that starts to get a little bit confusing for having, when we have three or more carbon atoms. You could have put the hydroxyl on that first carbon or on the second carbon, resulting in two different what we call isomers. We'll see a more clear sketch of this on the next slide, so we'll talk about that a little bit more on the next slide. But for now, I want to make sure that we see that if I put this hydroxyl group here or here, that I still have the exact same compound of ethanol. So wherever we sketch the hydroxyl group, whether it's the sideways or the up or down one, still ethanol. Those aren't different compounds. And then even if I put it on the first carbon here versus the second carbon, so I could put the hydroxyl here or here or here and still have what's called ethanol. Now, the key is only one hydroxyl group per molecule. If you have more than one hydroxyl group, you just have a different compound. Like you might know ethylene glycol is having a hydroxyl on the two carbons adjacent to each other. So this is ethylene glycol is having that second hydroxyl group. So kind of it is an organic alcohol. It's just not, a version of ethanol. So this is something that's not ethanol. So this slide here is showing the difference between what we might call 1-propanol versus 2-propanol. I want us here to see that there is a difference that in compound, like we get a different compound if we put hydroxyl on that first carbon versus the second carbon, we get a different compound. So 2-propanol, this is actually isopropanol present in rubbing alcohol. This would have a different melting point, boiling point, density, different set of properties from what we might call N or 1-propanol. Now, you might be looking at 1-propanol and saying, well, why don't you call it 3-propanol? Like if we're naming or numbering these carbons from one end to the other, you want the lowest possible number. So the lowest possible number would be 1 for 1-propanol. If you imagine putting this hydroxyl group over here, it's the exact same compound. So whenever we have compounds that are identical, we don't want to name them differently. So if two compounds are identical, they have the same name, like 1-propanol. And if they're different, isomeric, so whenever we have two or more molecules of the same chemical formula but different structures, they're called isomers. So an isomer of 1-propanol would be 2-propanol. Different sets of chemical properties. Okay, so let's get to some additional examples of naming. When we see this first name, we might look at this and say periodic acid. What's that? Well, think of it as periodic acid, and this cues us into periodate. Periodate is IO4 minus, is periodate. Iodate is IO3 minus. So I might be thinking, okay, I know this is iodate, so periodate is IO4 minus. In acid form, this would be HiO4. So HiO4 is periodic acid, or probably more thoughtfully said is periodic acid. Carbonic acid would be the acid of carbonate. So carbon-ic, so this is going to be the acid derived off of carbonate ion. So we're going to need two H pluses to balance out the charge of the CO3 2 minus. So we go H2CO3. H2SO3 would be the acid of sulfite. The sulfite is SO3 2 minus. SO4 2 minus is sulfate. So this is sulfurous acid. H2S as an acid, so we're being told to name this as an acid. So this would be sulfide. So sulfide is S2 minus. IDE ending ions in acid form go hydrosulfuric acid. N2O4. Now, so think categories. So obviously those are acids because you see the name acid in their formula. You usually see H's out in front. These are also acids, the next two. So we see, again, the word acid in the nomenclature system. This here is a binary molecular compound, so dinitrogen, tetraoxide. Now sometimes we call, and would call this tetroxide. I wouldn't be too concerned about tetraoxide versus tetroxide. Probably more commonly going to see this, but I think both are acceptable names. Pentane is the saturated hydrocarbon, so this is a hydrocarbon saturated in hydrogen with 5 carbons, so it's going to be C5H. How many hydrogens? Well, this is where I might just picture one of two things. I might just put 5 carbons in linear sequence, and then attach hydrogens to give me 4 bonds on each carbon. Look at CH3s on the end, CH2s in the middle. 1, 2, 3, 4, 5. Make sure I have the right count of carbons, so 5 carbons. I could also write this CH3, CH2, 3, CH3, just kind of summarizing it with these CH2s in the middle. And then if I just add up all the hydrogens, I would get 6 plus 6, so it should be 12 hydrogens in pentane. C8H17 with the hydroxyl group. This is an alcohol, the organic alcohol, derived off of what looks like octane. So octane, would be CH3, CH2, 6 CH3. So that'd be 6 plus 12 for 18. Remove one of the hydrogens, replace it with a hydroxyl group. This is octanol. Which pair formula and pair name is incorrect? So sodium bromate, or sodium perbromate. So that is correct. Calcium phosphite. We got a 2 plus, 6 plus, 3 minus, 2 of them for a 6 minus. Calcium phosphite, that is correct. Copper nitrite, or nitrate, screwing everything up with nitrate. Nitrate is a minus, making copper a plus. So that would be copper 1 nitrite. Continuing, we have Ag2CO3. So this would be silver carbonate. So CO3 is carbonate, 2 minus, silver plus 2 of them, silver carbonate. Silver is one of the ones that doesn't need a Roman numeral because the only ion we know for silver is silver plus. It's from our nomenclature chart that we don't need that Roman numeral. And then ammonium chlorate is NH4ClO3. So ammonium is NH4 plus, chlorate is ClO3 minus for ammonium chlorate. Okay, what did I do wrong? Because all of these appear to be correct. So sodium perbromate, calcium phosphite, copper 1 nitrite, silver carbonate, ammonium chlorate. I had to hit pause because apparently I just can't read. But this would be nitrate, not nitrite. So C is the one that's incorrect. I guess I too quickly looked. So nitrate, NO3. Nitrite would be NO2 minus. So copper 1 nitrite is the one that was incorrectly named. So another formula name pair incorrect question. So sulfuric acid. This is actually the wrong one right off the bat. So H2SO3 should be sulfurous acid. SO3 2 minus is sulfite. So sulfite, disulfurous acid, so H2SO3 should be sulfurous acid, not sulfuric acid. Sulfuric acid is H2SO4. And so then chlorous acid, HClO2, is correct because that's chlorite, the ClO2 minus, so chlorous acid. HC2H3O2 is a way of writing acetic acid, that's correct. HBr in acid form, so hydrobromic acid is correct, and H3PO4 should be phosphoric acid, which is correct. Which name formula? What are the formulas and compounds with the names octane and octanol? So C8H18, we saw this in an example a little bit earlier in the slides today, but CH3, CH2, 6 CH3s are saturated, 8 carbon count for octane, so 6 plus 12 is 18. And then if you remove a hydrogen, replace it with a hydroxyl group, you'd have C8H17 hydroxyl. So C8H18 and then C8H. If you combine, this is completely legal to combine this H over here. So B would be the best way to write the formula, C8H18, C8H18O. This is the same as formula CH17, then the OH group. Some other examples, some of these already were in examples today. HiO4 for periodate in acid form, carbonic acid, H2CO3, potassium peroxide, O2 with the 2 minus, so 2 potassiums, K2O2 would be potassium peroxide. Mercury 1 is mercury 2 plus. We just have to memorize that this is what we mean by mercury 1 is He2 2 plus. It's a weird example. It's one of our nomenclature chart rules for mercury that we're memorizing for mercury. Chloride, I'm going to need 2 of the minuses to balance out our charge, so Hg2Cl2. Mercury 2 iodide would just be the ordinary. Now mercury does form the ordinary 2 plus. Chloride, I'm going to need 2 of them, so Hg, this is iodide, but I minus is iodide, so HgI2. And then ammonium phosphite, NH4 plus, PO3, 3 minus, 3 of the 3 pluses to balance out the 3 minus. So NH4, 3, PO3. And then lastly, can we name water systematically? I just think it's kind of neat that you can go through water in a bunch of different conventional systems. You can name it as a binary. If so, you would probably call this dihydrogen monoxide. An acid of the oxide ion, so oxide is O2 minus, so oxides become hydro, so we call this hydro oxidic acid. You can name it as an acid of the hydroxide ion. You can say, well, this is hydroxide, and H plus is an acid of hydroxide, and you call that hydroxidic acid. You can name it as an alcohol of hydrogen. So if this is H2, replace a hydrogen with a hydroxyl group. So if we name it like an alcohol, this would be hydrogenol. So just kind of thinking of these different systematic names for water in these different systems. So that concludes these extra sort of review slides on nomenclature. Thanks for your attention.